Welcome guys for another topic of our Calculus 2, and our topic for today will be hyperbolic functions. So in front of you, you've seen many hyperbolic identities and hyperbolic formulas. Let's first look into hyperbolic identities. So if you could see, sine hyperbolic is just equivalent to an exponential function. So from here, you could see that sine hyperbolic x is equivalent to e raised to the power of x minus e raised to the power of negative x over 2. While on the cosine hyperbolic, the difference with cosine hyperbolic to your sine hyperbolic is just the sign between the e raised to the power of x and e raised to the power of negative x. We all know that tangent is equivalent to sine over cosine. The same in our hyperbolic. So here also cosecant, secant hyperbolic, and cotangent hyperbolic. If you could see figures below, this represent the figure of a sine hyperbolic. So it will have this figure, while on the cosine hyperbolic, it will have this parabola opening upward. And for the tangent hyperbolic, you will have this one with the y-axis at 1 and the other one in negative 1. So here we have 11 hyperbolic formulas. So some of those we'll be using. So first, before we tackle with the hyperbolic function in integration, let's first have recall of our hyperbolic identities. So let's try these identities. So sine hyperbolic 0, we'll try to substitute it here so that we will know what will be the equivalent. Because there are times that when we have hard time integrating multiple hyperbolic, then it is easier for us to solve if we use the exponential. So first, let us recall. So sine hyperbolic is equal to e raised to the power of x minus e raised to the power of negative x over 2, which gives you, where our x is 0, so therefore we have e raised to the power of 0 minus e raised to the power of negative 0 over 2. Any number raised to the power of 0 is equivalent to 1, right? So 1 minus 1 over 2. 1 minus 1 is 0 over 2. That will give you 0. Okay? So, sine hyperbolic 0 is equivalent to 0. Another one. For our cosine hyperbolic 0, let's try. So, identity for cosine hyperbolic 0 is e raised to the power of x, but the sign between them is positive. E raised to the power of negative x over 2. So our x here is 0, so you have e raised to the power of 0 plus e raised to the power of negative 0 over 2. So we have 1 plus 1 over 2 gives you 1. You have 2 divided by 2 is equal to 1. Let's try for our tangent hyperbolic 1. So, we know that our tangent hyperbolic is equivalent to sine hyperbolic, which gives you 1 here for our x, and cosine hyperbolic 1. Alright? And then, the 2 is equivalent, this one is equivalent to e raised to the power of 1, e raised to the power of 1, where x is equivalent to 1, minus e raised to the power of negative 1 over 2 over, let's make this bigger, over 2 over e raised to the power of 1 plus e raised to the power of negative 1 over 2. So therefore, this just equal to e raised to the power of 1 minus e raised to the power of negative 1 over 2 times uh, change this one becomes like this, e raised to the power of 1 plus e raised to the power of negative 1. So from here, we could cancel this one and that one, the 2. So what remains is e raised to the power of 1 minus e raised to the power of negative 1 over e raised to the power of 1 minus e raised to the power of negative 1. We could simplify it further. We have e raised to the power of 1 minus 1 over e raised to the power of 1, right? Because that is our, when we transpose this one, the reciprocal of this, you have 1 over e raised to the power of 1. And the same of for this, e raised to the power of 1 minus e raised to the power of 1 over e raised to the power of 1. So from there, we could get the least common denominator. So we have, for this one, that is e raised to the power of 1, e raised to the power of 1 divided by 1 times this one. So you have e raised to the power of 2. Because the power 1 plus 1. So it's just like this, okay? It's like you have 1 here, e divided by 1, that is e raised to the power of 1. So you have e raised to the power of 1 here, and the e raised to the power of 1 from 1 divided by e raised to the power of 1. Okay? So, minus 1 all over LCD is still e raised to the power of 1 divided by 1. So, you have e raised to the power of 1 times this one minus 1. So, we could have it e raised to the power of 2 because the power 1 plus 1, that is 2, minus 1 over e raised to the power of 1. And we could do the same what we do here, like this. So, e raised to the power of 1 over e squared minus 1. Okay? Okay, so this is actually plus. So, this is also plus. Okay. Okay, so this is plus. So, there, we can cancel this one, and our final answer will have e raised to the power of 2 minus 1 over e raised to the power of 2 plus 1. So, tangent hyperbolic 1 is just equal to this. Okay? So, these are some identities. Let's try more. Okay? We are not yet integrating. We're still not yet integrating. So, let's try more. Okay? So, let's have another example. Okay? So, let me erase this one. We will not yet erase this one so that you will have a guide, okay, with all the identities and formulas that we will be using while solving. So let me erase the first, okay, this one. Okay, let me erase. And let's try to show another example. It's our example number 4 for identity. Let's try cosine hyperbolic x plus sine hyperbolic x is equals to a raised to the power of x. So if you could see that if we have cosine hyperbolic x plus sine hyperbolic x, when we integrate it, there is a much easier way in doing this equation. So, if we could prove that this one is equal to this one, it's just simply you are integrating a raised to the power of x. Okay? So, let's try. So, first, we have, what do we need to do? So, let's substitute the equivalent of these two, that is a raised to the power of x plus e raised to the power of negative x over 2 plus e raised to the power of x minus e raised to the power of negative x over 2, which must be equal to e raised to the power of x, right? So from there, so this is addition. So we have, okay, we have least common denominator of 2. So you have ex plus e to the power of negative x plus e to the power of x minus e to the power of negative x equals this one. Okay? So, this one and this one, e raised to the negative x minus e raised to the power of negative x, we can cancel. So, what remains is just e raised to the power of x plus e raised to the power of x over 2, which gives you e raised to the power of x. Okay? So, when we add the 2, you have 2 e raised to the power of x over 2 equals e raised to the power of x. So, therefore, we can cancel this one, and we have e raised to the power of x, which is equal to e raised to the power of x. So, therefore, when we integrate this one, it's just simply, we could also integrate it using exponential. So that's the point of knowing the identities, the equivalent identity of a hyperbolic to its exponential form. So there are times that you forgot the identities for or the formula for the hyperbolic because it's too many. So I think this is much easier to memorize. This one, and here you have this one, and this one is the rule of trigonometry. So I think that this gives you an advantage if you know the equivalent exponential form. So let's try more example. Okay, let's try more example. So okay, can we see this first? Okay, now I'll erase. Let's have another example. Okay, still identity, so that later on when we do solving, we will know, okay, that is the equivalent. So for example, sine hyperbolic 2x is equal to 2 sine hyperbolic x cosine hyperbolic x. Okay? So let's prove that sine hyperbolic 2x is equal to 2 sine hyperbolic x cosine hyperbolic x. So let's try to prove, because if you have this one, there are times that the student will have a hard time what to do with this when you integrate. But if you have this one, it is much easier to integrate this one than this one. So there is an advantage when you know the equivalent identities. So let's try. So we know here that sine is equivalent to e raised to the power of x minus e raised to the power of negative x over 2. But here we have 2x, so you have 2x here. Okay? So this one, we have 2 multiplied by sine hyperbolic x, that is e raised to the power of x minus e raised to the power of negative x over 2 multiplied by e raised to the power of x plus e raised to the power of negative x over 2. So from there, we have, okay, let me write it around here. So, okay. So here we have 2 times 2, we have 4. So we multiply this one. Distribute this one, e raised to the power of x times e raised to the power of x. You have e raised to the power of 2x. E raised to the power of x multiplied by e raised to the power of negative x, that is plus e raised to the power of x minus x, right? This one multiplied with this one. Or we have that one, negative x, so that it is clear for you. Negative e raised to the power of x times e raised to the power of x, so that is negative x e to the power of x. Then we have negative e raised to the power of negative 2x, because we have power. Okay, from here, if you have two exponential multiplied with each other, the power will be added. In this case, x plus negative x, that is 0. And negative x plus x is still 0. So you have 2 e raised to the power of 2x plus e raised to the power of 0 minus e raised to the power of 0 minus e raised to the power of negative 2x over 4. Okay, there we'll have, okay, we could divide this one, so you have 1/2, okay, we have there 1/2. So what remains here, e raised to the power of 0 is 1, right? This becomes 1. E raised to the power of 0 is still 1. 1 minus 1 is 0. So what remains is e raised to the power of 2x minus e raised to the power of negative 2x over, wala na, sorry, there's no more over. So e raised to the power of 2x minus e raised to the power of negative 2x. So from there, I think it is already equal. So we could prove that this one, e raised to the power of 2x minus e raised to the power of negative 2x over 2 is equal to e raised to the power of 2x minus e raised to the power of negative 2x over 2. Diba? So, there are times that the benefit of knowing the identities is very advantageous, like this equation. So, you could have this one actually, but it is much easier if you know this one, because when you integrate it, it's directly, you just get this one as u du and derive that one, then you get this one, the integral. So it's still the same, because if you can see, this is the cosine. The greatest one, that is the cosine. Okay? So, okay? So now, we are done with those identities. Let's try to have examples for our actual integration of hyperbolic functions. So, we'll now use this formulas in order for us to solve. Okay? So, again, let me erase this one. So, have a cap. All of this is found in your e-notes. Okay, let's have an example. So this is for formula na. So let's say example number 1, the integral of sine hyperbolic x multiplied by, let's say, cosine hyperbolic, cosine squared hyperbolic x. Or let's say like that. Okay. Cosine hyperbolic squared x dx. Let's say we have this example. Okay. So from here, this is just like cosine hyperbolic x squared. Okay, guys, they are the same. Okay. So from here, again, we are not yet doing the techniques. We are still on the basic integration. We are knowing the different formulas of integral. So now, now let's try to solve. So let's have this. This is just equal to cosine hyperbolic x squared. They are the same. Okay? So let's say our u will be cosine hyperbolic x. And your du will be equal to, what is the derivative of cosine hyperbolic? If you say that is negative sine hyperbolic, that is wrong. In hyperbolic, when you derive cosine, that's still positive. When you derive sine, that is still positive. Compared to trigonometric, the derivative of cosine is negative sine, right? But in hyperbolic, that is still positive. Okay? So that is sine hyperbolic x dx. Okay? So, next, what will we do next? So, we get our dx. So, your dx will be equal to du over sine hyperbolic x. Then, we already have this. We need to substitute these values to your given. So, we don't have sine hyperbolics na equivalent. So, we have sine hyperbolic x. Cosines, this one you have multiplied by u squared, because your u is cosine hyperbolic, then you have squared, and your dx is du over sine hyperbolic x. Then here, when you multiply it here, this one is the denominator, this is the numerator, so therefore we can cancel that one. What remains is your u squared du. And this is our formula. So integration of powers. Here you have the formula number 4. Okay. So identity number 4 of Peterson's book. Okay. So now we have u squared plus 1 over 2 plus 1 plus c. Okay? Therefore, we have u cubed over 3 plus c. Or what is our u? Cosine hyperbolic x over 3 plus c. Okay? Okay? Can you look? Okay. So let's try some more example. Okay? Let's try some more example. So let me erase again because so that you could still check for those identities. Alright? Let me erase this one. So let's have our second example, which is, let's say, integral of sine hyperbolic square root of x, then divide by square root of x dx. Let's have this example. Okay. So first thing we need to know is what will be your u. So our u will be this one. Okay? That will be our u. So the square root of x, which is equivalent to x raised to the power of that one. Or when you derive, okay, we derive this one, you have 1 half x raised to the power of 1 half minus 1, right? That's in your derivative. So therefore, we have 1 half x raised to the power of negative 1 half dx. Okay? So we have that one. So from there, we need to get your dx. So your dx is equivalent to, when we get that one, you have 2 times du, okay, divided by x raised to the power of negative 1 half. So because this is just like x raised to the power of negative 1 half over 2 dx, right? So when we transpose this one to the other side, this one to du, we have 2 times du, then this one will be the denominator. Okay? So from that, we already get your u, du, and dx. We need to substitute into the given. We have integral of sine hyperbolic, that is our u, over square root of x multiplied by 2 du over x to the power of negative 1 half. Or we know that this one, if that is negative, we could transpose it above and then sign will be changed. So we have sine hyperbolic u over square root of x multiplied by x raised to the, change the sign, okay, times 2 du, right? Or in other form, that is equal to sine hyperbolic u over square root of x multiplied by, that is square root raised to the power of 1 half, that is square root of x times 2 du. Then numerator, denominator, we could cancel. So what remains is this one and this one. And 2 is a constant. We could move it outside the integral sign. So what remains is sine hyperbolic vu du. Then we have 2. What is the integral of sine u du? Sine hyperbolic, that is still cosine. Cosine hyperbolic u plus c. Or where u is equivalent to, what is the equivalent of our u? Our u is equivalent to square root of x, or x raised to the power of 1 half. So square root of x plus c. Okay? So kindly look at it first. Okay, so in that example, we could try another, we get this one, we could try to use the exponential function. So this is easier for a case, this is just direct integration. So when we use exponential, so therefore we have already this one, right? We already have this one. Okay? We already have this one. So take note of this. I will erase this part and remain this one. And let's try if the answer is still the same. Okay? Let me erase this one. Hopefully the space is enough. Sorry, I have only small space. So from there, we know we have the 2 and another, this is another solution. Okay, let's just erase from this above. And remember this u. Okay, let's just remember the u. Okay, let's have another solution. And we already know that integral, we have 2. We have already 2 because we moved the 2 already. Sine hyperbolic u du, right? We already have that one, which is directly we have this answer. So it is actually much easier for this that you get it already. But that's what my point here is, that it could, these identities, this e exponential could still solve it. Okay, but it gives you much longer means. So we have here 2 integral of, that sign is e raised to the power of u minus e raised to the power of u, negative u, over 2, okay, du. Now, we could have 2 integral of, okay, so we distribute the 2. We could separate this one, e raised to the power of u over 2 du minus e raised to the power of negative u over 2 du. And we could have 2 1/2 eu, sorry, integrate du equal minus 1/2 integral of e negative u du. Okay? So, integral of eu, we know that is still eu. But here, because there's a negative, we need to get our u as negative u, or let's say x na lang, of x u, and your du is negative, dx is negative d, that is negative du. So when you substitute that one, you will have negative here, so we need to put the negative outside. So from there, okay, so you have 2 1/2 integral of eu, that's still eu, minus integral of e raised to the power of u, the sign will be negative 1 over negative 1, which is negative, then copy this one. You have, so this becomes positive 1/2 e to the power of negative u plus c. Okay? So if you have our time, let's just, okay, so that it is clear, let me put it like this. So that is equivalent. So 2 1/2 integral eu du minus 1/2. So substitute it to the given. So you have 1/2 negative u is equal to x, in your du is negative, or transpose this one, or your dx will be, or sorry, your du will be equal to negative dx. So negative dx. So transpose that one, negative dx. So we move that one, we have 2 1/2 integral eu du plus negative times negative positive, we have that one, then integral ex dx. Now we have 2 1/2 integral of eu is eu plus 1/2 integral of x is ex, then plus c. While your x is equivalent to negative u, so therefore you have 2 1/2 eu plus 1/2 e raised to the power of, okay, raised to the power of negative u plus c. So I could say this is just to be rewritten as, they are all over 2 because they have the same 1/2. So you have eu plus e raised to the power negative u plus c. Therefore, you have 2. What is this? That is cosine, right? Cosine hyperbolic u, right? This one is cosine hyperbolic u plus c. And our u there, as I told you, you need to remember that our u is equivalent to square root of x in the beginning pa, when you derive this one. So your 2 cosine hyperbolic square root of x plus c. So if you could see, the two are equal. So therefore, you could solve either exponential or in hyperbolic. You just need to know what is the much more easier for you to do it. So it is advantage if you really memorize this one or understand how it works, but also there's a benefit of knowing those identities. Okay, so let's try another example. Okay, let's try another example. So first, just look at it first. So look if we have something wrong in our solution before we go to our, I think it will be our last example. Okay, so after that, let me erase this one already. Okay, let me erase. Okay, now let's try example number 3. So let's have integral of cosine hyperbolic x over cosine hyperbolic squared x minus 1 dx. Okay, so let's try to have that one. Okay, first what we need to do. So what do we need to do? So we need to recall identities. So we need to recall the identity for hyperbolic function other than the equivalent identity to its exponential function. So recall the Pythagoras na identities but in hyperbolic form. So recall, we have, so recall your other mathematics. We have cosine hyperbolic squared x minus sine hyperbolic squared x is just equal to 1. So if you ask me, sir, why is it negative? Because this is hyperbolic and not trigonometric. In trigonometric, this is equivalent to sine squared x plus cosine squared x is equivalent to 1. But in hyperbolic, that is cosine hyperbolic squared x minus sine hyperbolic squared x is equal to 1. So we could rewrite this one to be like this. So you have cosine hyperbolic squared x, you move it outside, this becomes positive, and move it inside, that is negative. So that will be equal to sine hyperbolic squared x. So now we have the equivalent of cosine hyperbolic squared x minus 1, that is equal to sine hyperbolic squared x. Okay. Now let's continue. So we have cosine hyperbolic x over sine hyperbolic squared x dx. Okay? So from there, what do we need to do next? Okay? So let's try to look some of these identities. So let's use some of those identities. We could have, let's say, we could separate the sine squared or sine hyperbolic squared into 2. So we could rewritten that one as cosine hyperbolic x over sine hyperbolic x times 1 over sine hyperbolic x dx, right? So these are still the same. When you multiply the denominator, that will be squared. Okay? So, but we could now get the identity. What is the identity of cosine over sine? That is cosine over sine, that is cotangent. So we have cotangent hyperbolic x times 1 over sine, that is cosecant x dx. So therefore, this one is just equivalent to cotangent hyperbolic x times cosecant hyperbolic x dx. So from there, we have, this is very cool because we already have this one. I think we have this one, where? This one. Cosecant hyperbolic, cotangent hyperbolic x. Okay? So therefore, we already have the answer. We have negative cosecant hyperbolic x plus c. So, right? So, that is the beauty of really having to know identities or formulas. Okay? So, I think that will be all for the hyperbolic functions, and wait for the next topic about inverse hyperbolic function. Okay? So guys, thank you and see you the next time.